Okay, so I'm going to do, now we're going to do the experiment. And so what we're going to do is use a spectrometer, and we're going to try to we're going to measure where the maximum wavelength for our color. Okay, what is the best wavelength for this guy? And got this fancy guy here. Before we had this big contraption that we had to use dials and all kinds of crazy stuff. Now I got this thing, and actually it's all wireless, and I have it hooked up to my phone. And so let me show you. So here's the website. Okay, so this is called Go Direct SpectraViz plus Spectrophotometer. Okay, and we got these things a couple years ago. And so we're gonna go ahead and use it. And before, you know, what the experiments we've done before, we use a computer and we use probes. This is sort of the update on this, so we're gonna use this device. So so I have it hooked up to my phone. So I downloaded the program. And I downloaded the app on my program, and what I did, it gave me the options of doing wavelength versus concentration, absorbance versus wavelength. And so what I'm going to do is I'm going to take one of the samples. Okay, what sample am I going to use? All right. So the first sample that we're going to use okay, so first thing I'm going to do is I'm going to use I'm going to use solution number 2 to figure out the spectrum. And so so first of all, I'm going to put in a blank cuvette, and then that's going to calibrate it. It's going to calibrate this, and then we'll continue with it. So I'll show you what we'll be using for okay. I need to get it. I need to get a disposable pipette. Figure out how to open them. So here's my disposable pipette, and that's what I'm going to use to transfer all right. Okay, so I'm going to be using number 2 for this, okay. Number 2 is 20 times 10 to the minus 5th. And so here's my cuvette. Okay, and they have a clear sides, and then they have a rib side. And what we're going to do is we're going to have the clear side. So what's going to happen is the light's going to pass through the clear sides, and it's going to go into a detector and detect how much light has gone through. And so okay, so it has an arrow on the spectrophotometer, and what you want to do is you want to stick the clear side so it sticks through there. And so I'm going to put a blank, and I'm going to blank it with water. So what I do is I can hold the outsides, and because it doesn't disturb the plastic, the clear plastic. But also what I'm going to do is I wipe it down, and there's a tiny bubble, and you can get rid of bubbles if you just tap it until they're all gone. And then what I'm going to do is I put the blank in there. And on my phone, it has finished calibration by putting blank. So I'm going to do that. Now I don't know how well I'll be able to show you okay, so what I'm going to do now is I'm going to transfer number 2 to another cuvette. And on my cell phone, it says collect, so I'm going to push collect. Alright, and there you go, okay? Pretty cool, I think. Alright, and so we want to stop. Okay, and what we're doing is we're looking at the peak, okay? And the peak is right there, and what we want to do is record that. Let's see if I can blow it up. So my data says the best point is the highest point. So I'm trying to spread it out. Okay, so I spread it out. Hopefully it'll get me a high point. Set negative numbers. I don't know why it doesn't get. So my max, all right, if you can see it there, my max is 545 nanometers. And so that's what I'm going to be using for the rest of this experiment, okay? I know, so what it did is basically what it did is it started at 450 nanometers, and what it did is it scanned, measured how dense the color was. It started at 450 and it went, changed the wavelength, and it did it instantaneously, okay? Normally on the old way you had to do one step at a time. So this just happened like a flash, all right? So, and what it did is it measured all the wavelengths and measured the absorbance, which is the density of the color. And it gave the highest density of the color to be we'll call 545. So what we want to do from now on, since that's our highest density, is we want to do all the experiments that we're going to do now at 545 nanometers. Okay, so we're going to set up the next experiment. And the next experiment is going to be called Beer's Law. Okay, I'm going to turn off the video. And oh yeah, I meant to say, I made a mistake with the calculations on the concentration. So I had to redo them. So if you look as part of what I'll send you is in terms of the lab experiment, as I'll send you how I made the calculations. I used the wrong. I should, instead of using I used number 1 for the to make. So for the next experiment, I said use number 1 to make the final solution. I should have used number 2, but it was basically the same. And hopefully take a look at the corrections I made on that. All right, so I'm gonna turn off the video so I can get ready for the next part of this experiment, which is called Beer's Law.